Hello, ladies and gentlemen. I hope I'm going live about now. Did not expect to be streaming today. Definitely not a little bit later than usual. But hey, many of you have told me that you would like me to come on a little bit later by an hour or so. This is exactly what we're doing right now. Let's see if that actually helps us get to higher live viewership, more likes, all the usual YouTube jazz, as we call it around here. Believe it or not, we are still not done discussing the latest Apple MacBooks, whether it's the MacBook Neo, the MacBook Pro. Now, there is very little actual new news, but there's still more reviews and benchmarks to dive in, a better understanding of the pros and cons of each device. And after giving, of course, all of these devices so much coverage from the original Apple newsroom reports to I see my Mac just switched to dark mode, and I was like, what's happening? You guys cannot see it because for the moment I'm in big mark mode, I'm in full screen. I already see Riley saying hello in the chat. I let you guys know on Twitter and on Discord. Thank you so much. The Discord has grown. Twitter subscribers have grown based on like one tweet, which is so weird how the Twitter algorithm works, especially if you don't have bullshit premium and stuff like that. I'm very grateful to you guys. I've had a lot of fun live streaming everything. I have heard, of course, your comments that you would like to see whether it's shorts or regular videos to help us grow even further. And I'll try to do that, but for now, live streams are still my priority. Up until like the middle of April, I'm super busy, so these streams are actually really taking some time out of my personal life and my work schedule, but I'm happy to be doing that because I love interacting with you guys. So if you're watching this, if you're enjoying this, please like the video, share it out with anybody who think might enjoy it, comment live. Anybody who has been here knows I love interacting with a lively live stream, getting your suggestions, your agreements, your disagreements. We have Rosa, a long-term viewer of the channel, watching. We have hello Yaya504 joining. Have not seen yet your name in the live chat. Welcome, brother or sister or non-binary entity, whatever you prefer. We are super open, super chill here. This is a community that celebrates technology primarily through the lens of Apple tech. However, we also love hearing from Android and Windows users. I generally have a more negative view on Windows than Android. Android, I think, actually offers more choice and everything, but that's a discussion we can get to maybe at some point if you sent me a very provocative super chat or something like that. And while I'm still doing the intro babbling, last shout out also beyond the regular YouTube jazz to also consider becoming a more direct supporter. Send a chat in the live chat, make it a super chat or a super sticker to support me financially. Every small donation goes a long way to help me make this channel a bigger part of my life and hopefully therefore a bigger part of your life. Shout out to all the YouTube channel members. You can become one as well. There are different tiers, including a new much cheaper MarkTech Neo tier. And then shout out to our MarkTech Pro members, KSB Wonders and Denise. And of course to our MarkTech Pro Max members, Angelica, Steve, Max, Maximus, and Jonathan. Couldn't be doing all this without you guys. Thank you so much. Second Wave Prod saying, hey, is this true? Yes. Now, this is unfortunately a little bit of a double-sided sword because I did put something somewhat provocative in my title. I know it will attract probably some people who dislike Apple or really like NVIDIA. Oh, and by the way, guys, before I get fully started, because my throat is already sore after the intro babbling, or at least dry. Cheers. Welcome to anyone. Have a drink, have a snack, have a good time with me. Probably should be about a 1.5 hour stream, not the 3 to 4 hours we've been doing for like the last few streams. So should be more relaxed, should still have hopefully a lot of information, a lot of entertainment, hopefully, depending on how you see me. Cheers. So, the RTX 5080 versus the Apple M5 Max Cheers to anyone typing cheers back. This primarily comes down to one benchmark, because you have to understand, I'm not hiding anything from you. I fully understand that in most gaming benchmarks, even the ones that are cross compatible between Windows and Mac OS, the M5 Max will probably lose more benchmarks than it will win. There are some definitive differences that are in favor of the RTX 5080 laptop GPU. That's primarily its super high power consumption and therefore its high clock speeds. And for the other thing, it's its usage of GDDR7 memory, which allows it to have almost 50%. And I actually think it's around 50% more. So the M5 Max is 614 gigabytes per second. RTX 5080 laptop bandwidth, that's somewhere around 900. I know I mistyped bandwidth, by the way. Yeah, it's 896. So it's almost 50% faster, basically so close to 50% that it kind of doesn't matter. This will help, especially in games that have super advanced ray tracing effects. So things like, think of features like path tracing. That's in older games at this point, like Cyberpunk 2077, we always use it because it's one of the bigger AAA games that exist on Mac. By the way, right around the corner, Crimson Desert is launching basically on every platform under the sun right now. In basically a week on March 19th, and it's coming out simultaneously to Windows, the major consoles, and Mac. So this will be an amazing opportunity. Now, again, I have an M1 Max MacBook Pro. It's not going to be very relevant, but this is going to be something that definitely will get me out here again, adding more benchmarks. So we'll have to see. This is now a Metal 4 game. So this is using Apple's latest graphics API. This is something that CD Projekt Red, the developers of Cyberpunk, have promised for Cyberpunk 2077. But this has now been like half a year in the works. We still don't have it. I don't know if there are any issues with Metal 4 from Apple's side, or CDPR is just not investing the necessary resources. They obviously did a port to the Nintendo Switch 2. Like, I know they're internally switching over to Unreal Engine, which is disappointing to say the least. I prefer proprietary engines like what Crimson Desert is using here, what Capcom is using for Resident Evil Requiem. I think these games tend to either look better or run better, and sometimes they do both versus Unreal Engine. So that's plus Apple, of course, does not have the best relationship with Tim Sweeney, the CEO of Epic Games, who has railed against Apple's App Store policies. He wanted to push in like App Store commission-free V-Bucks, or I don't know. Are those called V-Bucks in Fortnite? I don't care. I don't play. I don't care. I guess that was like a Freudian slip when I said I don't care. I wanted to say I don't know, but I think both kind of apply. Okay, the video seems to be working fine. Oh, we have a couple of people watching. Once again, please like if you haven't yet done so. That helps tremendously. Let me know what you think, or give me suggestions what I should react to. But let me get to my initial claim about the RTX 5080 laptop GPU versus the M5 Max. Yeah, M1 Max 993. Realistically, how long does it take for CDPR to utilize Metal 4 for Cyberpunk? How many months? This is entirely dependent on the size of the team that they put on it. Now, you should understand that Cyberpunk 2077 is a feature-complete game. So there are not going to be big expansions on it. They are depreciating that engine in favor of Unreal Engine. They're working on like one big expansion for The Witcher 3 at this point. So everything that they're doing, whether it's maybe slightly further optimizing it on the Switch 2, or hopefully bringing Metal 4. These are all now side projects. So unless Apple comes in and basically says, look, guys, this was contractually obligated for you, or what is happening? Do you need money, right? And then we will know. But it could be like sometimes things that were promised, they just don't happen. And that's unfortunate, but that's a part of the nature of gaming announcements in general. And specifically when it comes to a more niche platform like macOS. But this is primarily gaming. Just from the selection of games, obviously there's no competition between the M5 Max and the RTX 5080. Even if the M5 Max was somehow 20% universally faster in every game that was on macOS, I would still tell people, you know what, you should probably get a laptop with like an RTX 5080 or if even a 5090 if you can afford it, if you can live with the compromises. But one thing that NVIDIA used to absolutely rule is rendering, 3D rendering. They were obviously the first ones to have hardware accelerated real-time ray tracing on the RTX 2000 series as far back as 2018. It took Apple 5 years to offer something similar in the form of the M3 chip. So Apple absolutely has not been the greatest pioneer of graphics technologies. Part of that was because, of course, they were working primarily with smartphones that are very resource limited, power limited, memory limited, bandwidth limited, right? So there wasn't even enough incentive to really create like, oh, here's like our version of RTX. Now, there is an incentive for Apple to make a better version or a homegrown version of DLSS or FSR. That obviously happens in the form of Metal effects. Now, but ever since Apple introduced hardware accelerated ray tracing, it's now been 3 hardware generations. It's M3, M4, and M5. Apple has done tremendous work to improve here. And we can see the RTX 5080 laptop GPU. Now, this is Blender 5. So for a while, this benchmark was limited to version 4.5. And that's why I didn't really want to react to any kind of initial Blender tests. I think we reacted to like 1. And it was very promising for the M5 Max. Benveni joined the stream. Welcome, brother. So glad to see both familiar and unfamiliar faces. Means so much to me. Let me check everything. Yeah, it all works. I'm sorry. I'm a little bit paranoid about the live stream after like the last couple of streams had some issues. Not necessarily in terms of the actual live stream, but like audio and whatever. I kind of effed up a little bit. So it's less noticeable to you, to be honest, than it is to me. But whenever I looked at the chat, I'm also looking at like, oh, what's the video quality like and stuff like that. Because my internet at home has also been a little bit unreliable. So it's like the perfect combination of like, I come home tired, I'm less sure of myself of what I'm doing. I made a mistake once with OBS and Steam being open in parallel. And then my internet also doesn't want to act perfectly. And now I'm extra paranoid. So median score for the RTX 5080 laptop GPU. Thankfully, a very engaged community of RTX 5080 users. Already 344 benchmarks. That's with the newer benchmark, by the way. So obviously, there are way more benchmarks if you look at like a Blender version 4.5 and stuff like that. Benvini is saying, my battery in iOS 26.4 went downhill after beta 2. Mine has been a little bit down. I wouldn't say downhill just because the 17 Pro Max delivers such good battery life in general, but it's not the greatest on the last 2 betas. So we'll have to see. I also changed some settings around, so maybe that's partially to blame. But I guess we'll have to see once like 26.4 beta 5 and 6 roll around. We'll get a better picture of it all. But let me actually get back to what I was starting all along with. 6,700 points in Blender. So this Blender, of course, is heavily dependent on overall compute, but specifically the quality of your ray tracing acceleration. And with that, it's also dependent on bandwidth. Now, it might not actually be always as dependent as like ray tracing in a video game that like happens live, has to deal with your input and stuff like that, might have to calculate parts of the world, right? Obviously, most of that happens on like the CPU, on the world thread and things like that, but still the GPU has like particle physics and things like that. Blender, especially when we're looking at a Blender photo and like not a video generation, it's a little bit less bandwidth limited, but still, I mentioned already that the 5080 laptop has roughly 50% more memory bandwidth than the M5 Max, so that is partially in play here. Well, now look at where the M5 Max is at. A chip that consumes less than half the power. Now, the 5080 laptop GPU, usually most of them are tailored towards like 130 to 150 watts. Technically, just like the RTX 5090 laptop GPU, which sits here and has up to 24 gigabytes of RAM rather than 16, you can push it up to 175 watts. So this is why we're looking at some median scores. We'll see there are some outlier scores like 8850. There are also outlier scores, it should be mentioned, for the M5 Max. So some scores at around 7400, and I've even seen some tests closer to 7500. So I'm using the median scores while fully, of course, acknowledging that there will be higher scores of both the 5080 laptop GPU and the 5090. But when you're saying Mac, I assume you're asking Mark, do you think M6 lineup will be much more expensive than M5 lineup? Everybody's saying this on X. I almost feel like that, like this was like based on one YouTuber. My speculation is actually that the base M6 MacBook Pro is not getting tandem OLED. My speculation is that tandem OLED is coming to the M6 Pro and M6 Max MacBook Pros. Apple will try to sell out of mini LED parts with that still very fast. It's probably going to be faster in some ways than like an M4 Pro 20 core. Like with the base M6 MacBook Pro, they'll probably give it like who knows, maybe M6 brings like Thunderbolt to the base version at that point, right? That's going to be something to write home about. Maybe even faster storage. So there are a lot of leverages that, like, I don't believe the latter, like Apple just doubled storage from M4 to M5. So there are a lot of levers that Apple can still pull. Now, there are RAM and storage considerations. People misunderstand just how small RAM and storage are as part of Apple's overall pricing. Apple charges you an arm and a leg for RAM and storage, but that's because that's where they generate a lot of their like excess profit, right? It's where they actually might approach like a 50% profit margin at some point, while usually their hardware margins are somewhere in the mid-30s, right? And their base versions have even lower profit margins, of course. So that's how you get to like that median result, or medium, I guess. So in that regard, I think that M6 will probably start at a very similar price point, maybe with like $100 price increase here and there. Apple just increased storage speed, RAM speed, despite the ballooning component cost. They technically, the 1 terabyte model costs as much as it did before. It costs less on the M5 version, right? So if we're looking here at apple.com. Sorry, by the way, guys, this is the nature of the live stream. I tend to get distracted if a topic is really interesting to me, or if you sent a super chat. But we'll get, of course, to the main topic at hand. So the reason why I do want to comment on this is because I have seen this, and I've seen people basically speculate that prices would go up by like 20% or something like that. And I promise you that that's not happening. People try to compare it to like the iPhone 10, which, guys, I know we all want to feel young, But the iPhone 10 is going to be almost 10 years old by the time the new, it's going to be at least over 6 years old, over 9 years old by the time these new MacBooks launch. It's not that much more expensive nowadays to add OLED. And also don't forget, these laptops use mini LED. Mini LED is far more expensive than even a ProMotion regular LCD. So tandem OLED, yes, it is going to be more expensive here to add, but it is not going to be the same as, for example, the 11-inch iPad Pro that had LCD jumped to tandem OLED. And then the 13-inch iPad Pro had mini LED and jumped to tandem OLED. And Apple also did some other stuff alongside it. They changed base storage and everything. So in the end, you were paying $100 more for the same amount of storage. I don't think that's crazy. So for the base version, my speculation is it's either not getting tandem OLED, and at that point we're keeping the same $1699, 1 terabyte, 16 gigabytes of RAM, right? Or it is getting tandem OLED, and then it's being maybe $17.99. Maybe Apple could even resurrect their $50 price intervals, because remember when that were a thing, they could do $18.49. Or they'll just say, my problem is that this laptop becomes very, very unattractive if it gets super close to $2,000 with the base chip. And so when we look more specifically here at the M5 Pro, and we imagine that now being the M6 Pro, right? That now starts, of course, at $2199. That's with 24 gigabytes of RAM and 1 terabytes of storage. If you just do the same 24 gigabytes of RAM, probably, by the way, the same memory speed, there's a good chance that Apple will just mass order the shit out of LPDDR5X 9600 for this year, which does include the A20 chip, which does include the M6 chip, and then they will just use the 2-nanometer advantages and putting the RAM even closer to the die due to the new WMCM packaging to give you a better RAM experience, right? And then the year after, I could see Apple utilize LPDDR6 memory, whether it's the very base version of 10,700 megatransfers per second memory, or even something faster in the 12,000 megatransfers per second or 12 gigatransfers per second range. Probably not the full 14.4. I don't think the spec is that far. Well, technically that would be a validatable speed. It would be faster than I think is actually possible. Part of it is that even the first wave of LPDDR6 chips is actually being built on the same roughly around 10 nanometer class nodes as later LPDDR5.6. So while a lot of like Micron, SK Hynix, they are promising you 20% efficiency, quite honestly, I do not actually fully believe them. Maybe by the time you integrate it through like WMCM and put it really close to the die, maybe, yeah, well, that's about the efficiency gain we'll see. But that's now getting a lot of help from outside the node. Ben Vinny saying, I remember a lot of people rushed to get the 16 lineup because there were rumors the 17 would have a price increase. Exactly, and we see that a lot. Like, I remember people, when the Apple Watch Ultra came out, the original, right? A lot of people were basically speculating that it would be $1,000, and with it, the base Apple Watch would probably move from 400 to around 500, right? Well, what happened? Well, it was 800, and the regular Apple Watch stayed at 400. People underestimate how much leverage Apple has over their production lineup, how much they are willing to pay it forward. It's not like they will suddenly start writing red numbers and put themselves into the negative, right? But if they have to sacrifice 2 to 3% profit margins, knowing that the new platform they're building, whether it's this new design MacBook Pro, the tandem OLED, right? They will be able to use that panel, those production facilities, the expertise from from the engineers for at least another 5-6 years, right? But over that time, that means even if the profit margin shrinks a little bit by the introduction of M6 Pro, M6 Max, those margins will then expand once again with M7, M8. Obviously, the list goes on. Angelica saying, I am untiring and streaming with a high level of intelligence. Always appreciating nice words. Give me, feed me compliments. M1 Max 993. Could we get the M5 Ultra this year? Sorry, I'm lisping because I'm getting tired. We are definitely getting the M5 Ultra this year, probably around WWDC or summer, right? I know we orient our year around like Apple events, but for regular people, it's called summer. So we are overdue an M5 and M5 Pro Mac Mini, right? There could be an M5 iMac, but there could also be an iMac that finally goes a little bit beyond and introduces like Pro or even Max chips to the lineup. So maybe an iMac that uses like the screens from the Studio Display or even the Studio Display XDR, which at that point would be a very expensive $5,000 iMac, but that's a different discussion. And of course, the Mac Studio. Now we are also overdue, long overdue for an M5 or even an M4, or heck, even an M3 Mac Pro. But everything points towards that the Mac Pro will be discontinued in favor of the Mac Studio. That's what partially the BHD video that we reacted to was about. And so the point was that with the Mac Studio, we are, of course, not just going to get an M5 Max version and then keep around M3 Ultra. That would be ridiculous. Don't forget, M3 Ultra is not just older than M4 Ultra would be, of course, which never existed, but it also uses very slow memory at this point. When M5 Ultra comes along, all things being equal, it will have 50% more memory bandwidth, right? From 6400 megatransfers per second on a 1024-bit bus, that's a little bit over 800 gigabytes per second, while this would be 1228 gigabytes per second. So this would be monumental, and this is what we are getting. I hope Apple also resurrects the 512 gigabyte RAM version, and I would love to see Apple introduce a 16 terabyte storage configuration. All of that might, though, be limited potentially by supply chain issues, and of course Apple building their own server infrastructure in the form of private cloud compute at the moment. But yeah, we are getting M5 Ultra Mac Studio by the middle of the year. I think they did the right thing by skipping the M4 Ultra. Well, no, they did not. Because the problem is when they skipped the M4 Ultra, the M3 Ultra did not come before the M4 Max, right? So by I'm happy that they didn't waste internal resources. If they had M3 Ultra ready, like, it's fine for them to not design an M4 Ultra if they know M5 Ultra is going to be better, right? But my problem with that is, well, then why even put out the M3 Ultra? Is it just to have those ultra high RAM configurations out there for like super big LLMs and things like that? Obviously, it would be better if instead of the M3 Ultra, we got the M4 Ultra. But since we didn't get M4 Ultra, I hope M5 Ultra comes along a little bit faster. You're saying it would be good if the Ultra chips came out every 2 years. Like, it depends, right? If Apple can handle all chip upgrades on an annual basis, right, that would be insane. And Johnny Cerrugi is an absolute machine, and his team is just like Terminator-style robots at this point. But if they can make it work on an annual basis, the problem with 18 months is 18 months ends up often being a little bit confusing, right? Because that usually means you skip one generation, but then you do one generation after the other. Then you once again skip one generation, then once again you do one generation right after the other. So a little bit the problem right now that we're in. And obviously the Mac Pro has been part of the problem too. I think internally Apple might have been trying to resurrect it, give it something more interesting and more powerful, but then ends up not really finding anything to make it work. That's very much speculation on my front. There have been rumors, more precisely, that Apple might be working on a much smaller Mac Pro. Obviously, that didn't pan out. I would be surprised if it ends up panning out, because if you make the Mac Pro much smaller and rob it of some of its PCIe expansion, like, at what point is it just a Mac Studio with maybe two PCIe by 4, or maybe one PCIe by 4 setup and one like PCIe 16, which also is questionable because you don't actually support external GPUs or dedicated GPUs on it. I am rambling. I know that we have a lot to discuss, but so the 5080 laptop GPU, 6700, the M5 Max, almost 10% faster, about 8%. This is monumental. Now, why? Why, for example, am I so happy to compare it to the clearly slower 5080 laptop, but not as much to the clearly a little bit faster 5090 laptop? Well, this is because these things, even the 5080 laptop, even the 5070 laptop GPU, which obviously performs way worse, they exist in a completely different class of experience. Neither the 5080 nor the 5070 Ti or even the 5070 laptops will give you full performance while unplugged. For that, it's more like 60 Ti and 5060 level, right? So you have already that difference in experience. You can take your laptop everywhere. Will it last super long while you're doing like super extensive Blender tasks? Probably not, but most likely it will last longer than this or give you so much more performance, which unfortunately Blender you can see some of these super low scores. These low scores could come from like efficiency mode settings on a laptop, or it being unplugged and stuff like that. Obviously, the real truth is somewhere here, right? I'm not going to be magically saying, oh, this chip is actually a 3800 point, right? GPU. But then the other point, of course, is that the GPU limitations, right? From these GPUs, the RTX 5080 laptop is a 16 gigabyte GPU, right? It exists on a 256-bit bus, and it uses 2 gigabyte modules using GDDR7 memory. The RTX 5090 is actually super similar to it. It has obviously more shaders, but it's still built on a 256-bit bus, but instead of using 2 gigabyte modules, it uses 3 gigabyte modules, and that gives it 24 gigabytes of memory. The M5 Max starts with 36 gigabytes of unified memory. Even if you were to magically erase like 12%, like let's say you erase even half of it for like running your tabs in the background or something like that, because obviously a 5080 laptop will still have memory for its CPU, right? That's still more graphics available memory than on a 5080 laptop. If you go with the Max enabled one, that's 40 cores instead of 32. Unfortunately, there are no benchmarks for the 32 core version. Then you'll have double the memory, the GPU available memory of the 5090 laptop, right? And at that point, honestly, the M5 Max MacBook Pro is probably going to be cheaper in a lot of ways. Like if you get this with like a super high-end, like 24-core Intel chip, like which still, by the way, won't also give you the single-core performance of the M5 Max, nor the multi-core performance, nor the efficiency. This is just a monumental difference in how you will utilize those machines. And in that regard, the M5 Pro is also going to be a great offer, because at $3765, given that when you're using these devices unplugged, right, your power will drop by 50%, sometimes more. that will now put it closer to the M5 Pro. Now, yes, there will be some things still in advantage of the 5080. And again, I'm not talking about app compatibility, game compatibility, Windows ecosystem benefits. I'm not denying that. This is not a, oh, I'm bashing on Windows or I'm denying all of macOS downsides video. But this is now exactly like if you're just using Blender, you're now getting similar performance from a machine that's now cheaper, and that's an Apple machine. And now this machine also offers way more battery life, and most likely the difference in now CPU performance, because don't forget the 20 GPU core version of the M5 Pro gives you also the full 18 cores on the M5 Pro, representing a 30% increase in CPU performance over the M4 Pro, and still a 15% improvement over the M4 Max. So the M5 Pro got the biggest uplift this year, and this is partially why the video I actually want to react today is from Miani, who analyzes specifically the M5 Pro, right? And if we'll look even at the M5 Pro 16 cores, you will see even that is like half the performance of the RTX 5080. Again, imagine this unplugged, and now imagine the price difference, because on the 14-inch version, this is a $3,200 laptop that, yes, still offers you more memory than this laptop, right? Which likely costs way more, has way worse battery life. And this is why if the M6 Max becomes $100 more expensive, or hell, even $200, right? Let's say it starts at $2,400 for the 14-inch version with 1 terabyte, 24 gigs of RAM, M6 Pro, and of course the tandem OLED screen and all the other benefits. The redesign, potentially a better vapor chamber based cooling system, all that stuff, right? Like, I would still argue it's worth it. Yes, a 5090 then will now be faster, of course. The 5090 has more shaders. That also allows it to clock a little bit lower when unplugged, but distribute that workload over more GPU cores. And that usually gives it not just more performance than the 5080 laptop, but also more efficiency. So maybe at that point, once you have this performance, it will be faster, of course, than a 16-core M5 Pro, maybe even faster than a 20-core M5 Pro. But now you're comparing, but now its CPU will be completely like out of whack, right? Why would you do that if you can get an M5 Pro or even M5 Max MacBook Pro? Obviously, if you have the money for the latter. Don't forget, the M5 Pro this year now allows you to get 64 gigabytes of RAM on the MacBook Pro. Previously, that option was limited to the M4 Pro on the Mac Mini. The M4 Pro on the previous MacBook Pro only got you up to 48 gigabytes of RAM. So now, obviously, you'll have to pay a little bit for that. But honestly, these prices are not as that crazy now once you start comparing it to like workstation laptops, right? There are some laptops and some desktop GPUs that are more like Quadro style GPUs rather than GeForce. So they're more designed for the pro market than the gamer market. They will have more memory. They will have drivers that are specifically validated for pro apps. Yeah. But now you're looking at paying potentially way more money than a MacBook, which usually Apple is the one that asks you a premium. You will still have less memory, and now you will have a system that's really unbalanced, right? Because here you also get the Max CPU, here you get the Max CPU, you get all the great battery life alongside that still. Sorry, here you get the great CPU, not here. Well, on these other devices, obviously, once you unplug it, that CPU also goes down the drain. It's not just a compromise for the GPU. And if you are working simultaneously, even just on your regular system, sure, of course, an Intel 285, what is it, HX or it's not a K on laptops, or just H, whatever. That was just a guess on my part. Intel 285HX. Tell me if this card exists. Yay! My understanding of the stupid Intel branding actually gave me a little bit of an understanding. Uh, Show me its Geekbench scores. CPU monkey, there it is. That's the 280. Oh my, look at this. This is less than an M3. This is competing with honestly, this is, to be more exactly, competing even more with M1, but it's roughly M2 level performance. Now, this, I assume this is not pushing the maximum. The maximum would be more like 3100 pointy. But man, wait, is there really nothing? Like, okay, this is the HX. Man, but now you're paying more, giving a battery life, all to get to finally M3 single core level performance. Cinebench, Command F, give me Geekbench. Yeah, 3,000 points. Yeah, so this is around M3 level of performance. And in multi-core, this actually, of course, is, yeah, obviously, this is more like M4 Pro levels of performance, not M5 Pro, not M5 Max. Obviously, M5 Pro and M5 Max share the maximum CPU performance. You can get the binned version with 15 GPU cores. But yeah, so this is what you would get in a laptop with like roughly this GPU, and now you're compromising the moment you're unplugging it, both the GPU, both the CPU, and you don't forget, you got a laptop that's pretty thick, pretty heavy, runs its fans super loud, because just the GPU alone can consume more power than the entire M5 Max SoC in the MacBook. I guess you can kind of push it to around 200 watts in the Mac Studio, but not in Apple's notebooks. And then you have the CPU that consumes sometimes as much power, honestly, as that like almost 200 watt GPU, at least if you push it to the max. And now you're like in such a completely different class of experience of the things you have to consider. Carrying around more, accepting lower battery life, right? Accepting wild performance differences between plugged and unplugged. And usually these kinds of laptops will tend to have worse quality of life features. You will actually find, for example, like the best like speakers on Windows laptops more like your premium thin and lights like Dell XPS than your more gaming oriented like super overbuilt 18-inch laptops and stuff like that. These laptops might also tend to have more of a 16:9 aspect ratio screen, which isn't really the greatest for like web browsing, taking notes, working with documents, or God forbid, actually reading a book. So this is not to say that these laptops, these GPUs, these CPUs are now suddenly entirely worthless and everyone should be switching to Apple. But these are things that I often see unaddressed. I've seen some people online recently talk about, and I've seen some people post that in the Discord too, saying, oh, but the RTX 5090 is only $3,000 by itself. And don't forget, the RTX 5090 maxes out at 32 gigs of RAM. That's less than the binned M4 Max. It consumes 600 watts of power. Obviously, it's a dedicated GPU that goes into a full-on tower. It needs a good CPU, a good motherboard, a good power supply. You will not pair it with with a cheap CPU, with cheap memory, right? So at which point, no, it's not $3,000. It's more like $5,000, and you're way more, of course, like even with a 5090 laptop. Obviously, I mentioned its performance going down when unplugged, but you can unplug it and take it with you. A 5090 desktop, not so much. But yeah, so this is for the main statement, for the main thesis of the video. Basically, there is, however, one review I really wanted to react to because it does provide a lot of benchmarks. Luke Miani, somebody who I respect both as a content creator, but also he is very outspoken about his very humanitarian political views. This channel is not political in nature. Obviously, I'm not telling you to follow him because he's anti-Trump or pro-Democrat or something like that. But I think he's genuinely a very nice person, and hopefully he doesn't demonetize my video for reacting to his video, because I actually did not ask him for permission. This entire stream was a very spontaneous decision on my part. But hey, if he shows some worries online about me reacting to it, tell him that Mark is a nice guy and that he is doing this out of respect and appreciation rather than like, well, sometimes I will react to things to criticize them, which I guess is even more free use. But sometimes I'll just react to things because I need the content and somebody did the work, they did the benchmarks and things like that. So put it at 0 and let's get started.
6 years ago, when Apple Silicon first came out, I was mainly concerned that they had done so much on their first attempt that they would struggle to improve in future generations.
So what's interesting, I feel like Apple has come away from talking a lot about teraflops, because by the time with like around the A15 chip, which is like M2 GPU time, they did double FP32 throughput, but I'm not sure if they did it exactly like Nvidia has done it. So their teraflop numbers started lagging behind the competition, while in real world performance they were actually catching up more and more to Nvidia, while I would also argue still delivering a much better GPU than what, for example, Qualcomm can deliver or what AMD can deliver. I guess Intel can be sometimes comparable between when you look at like Panther Lake versus Apple M5. When you look at MediaTek, you'll find it's also quite good at like ray tracing, similar to Apple, but then usually consumes quite a hefty amount of additional power. We'll also have to see if at some point we can react to further A19 and Snapdragon 8 Elite Gen 5 and MediaTek Dimensity 9500 benchmarks through Geekervan, which has been obviously our go-to source for all of this. But after their drama surrounding Chinese smartphone vendors really cheating the shit out of smartphone reviews, they would hand reviewers golden samples. They would pre-install software on those devices that would make them show a wrong frame time graph in a recording video. So your eye might actually see, oh, this video game is not rendered perfectly smoothly. There are some frame time spikes and stuff like that. But then the graph would actually be perfectly flat. Or they would force the game to actually enable settings like variable rate shading, which partially can degrade a game's visual quality, and not let you turn it off, or sometimes not even tell you that that feature is on at all in the pre-release version. And then the official release comes out and magically now those settings fully work as intended. So, and it seems like Geekervan might be almost dead. Like, they apparently put out a MacBook Neo review on like some separate website, so not Bilibili or whatever in China, and I hope that they will still return to YouTube. Usually their YouTube videos or Weibo, whatever. What is Bilibili? Or is it Bilibili and Weibo something different? I always forget. Obviously I don't interact with it. But usually their YouTube videos came out a few days after their video comes out in China, because they don't even translate it fully. They just put subtitles under it. But there hasn't been a new video for over a month on YouTube. And their MacBook Neo review, which has come out in China on that separate website, has not been posted to YouTube. So apparently they put themselves into some deep shit with the Chinese government and probably some very influential Chinese companies. Hopefully that does not happen to other reviewers. Boom, transition again to Luke Miani.
But boy, was I wrong, because for the past 4 generations of Apple Silicon, they have delivered impressive gains.
Yeah, we are now we have had 4 updates in 5 years, right? So it actually was slowest when they were transitioning from M1 to M2 because it took them 18 months there. Actually a little bit over that. And that's because they introduced the M1 Pro and M1 Max a full year after the base M1, right? So by the time we thought, oh, maybe there would be an M2, they introduced the Pro and Max chips by the end of 2021. That's still the MacBook Pro that I'm using. And then only in mid 2022 did they introduce the M2, right? And then the M3 they introduced by late 2023. Now they're actually on an annual upgrade cycle completely, launching a new generation M4, M5 by the end of the year, M4 obviously launching by the end of 2024, M5 launching by the end of M4 launching by the end of 2024, M5 launching by the end of 2025. So Benveni, to your suggestions to put the Ultra on a 2-year upgrade cycle, that would also mean it's always a year outdated at the very least, right? Well, after a year, it becomes outdated. You get what I mean? So I'm not sure if Apple can hire enough people to make all these ports work. Don't forget, M5 Pro, M5 Max, they might seem somewhat straightforward in terms of upgrades. It's the same it's the same GPU core count. It's a somewhat different CPU layout, but still roughly understandable, right? Going from 16 cores with 12 P cores and 4 E cores on the M4 Max to 6 super cores and 12 performance cores on the M5 Pro unbinned and M5 Max. But they're also bigger internal changes. Like they're the biggest change since the introduction of M1 Pro and M1 Max. I would argue they're even bigger than M1 Ultra and M2 Ultra because while Ultra Fusion is interesting, Apple always had some issues with making scaling work on those chips. M5 Pro, M5 Max are chiplets that actually seem to scale almost perfectly and seem to come with no noticeable downgrade in terms of efficiency and therefore battery life to the overall device. So fantastic things. And we are still in the same year. We might be getting the M6, potentially M6 Pro, M6 Max, right, like 7-8 months after this. This is absolutely crazy. Massive respect. Don't forget, between the RTX 5080, the RTX 5000 and the RTX 6000 series, this might become a 3-year gap. And the RTX 6000 series might actually be still mostly on 3 nanometer by the time Apple will be close to launching an N2P chip. So absolute craziness, and Apple will likely keep their efficiency advantage. So for a while they were so much slower, especially in like ray tracing tasks versus RTX cards, that despite Apple using a newer node, for example N3E on the M3 chips versus 4 nanometer on the RTX 4000 series, I would argue in terms of performance per watt, those RTX laptop cards, which obviously are clocked a little bit different, are like they have the max Q power efficiency optimizations, right? They're better than their desktop GPU counterparts in that regard. I would argue they beat DM3. But then NVIDIA got lazy. They got super successful with their server market. The RTX 5000 series launched on the same node as the RTX 4000 series. Still N4, maybe N4P, but that's apples and oranges. That's like a 5% improvement at best. The architectural improvements were slim. The actual benefit of the faster memory bandwidth is barely felt from the RTX 4090 to the 5090. The 5090 gets its extra performance from literally having more cores and therefore consuming almost a linear amount of extra power with those extra cores. So, meanwhile, Apple in the meantime jumped from M3 on N3E for N3, sorry, M3 was on N3B. Then they jumped to M4 on N3E. They did not fully double ray tracing performance, but they definitely got in some cases close, especially once we got like later Blender versions that were fully optimized and stuff like that. And now they have M5, which offers another 20% benefit to the ratio of raster to ray tracing performance, right? So they did improve raster by like 20%, but then they improved ray tracing by like 35 to 40%. Carlo Ferguson joining the chat saying hi, asking how was your day? Tiring, to be honest. I still went to work, even though I technically could have worked from home, but I did not want to take all the files with me. I had a really bad stomach ache, but thankfully that one is now gone. Hooray to Coke. It cures all ailments. This video is not sponsored by Coca-Cola, but if you can find a better advertiser for Coca-Cola than I, like, congratulations to you. I actually went to not the Apple store, but to an authorized reseller by my, next to where I live. I was able to check out the MacBook Neo and the M5 Pro and M5 Max MacBook Pro. But now I'm feeling a lot better. Don't worry, Colin Ferguson saying, "Oh, how bad for you?" Yeah, I am feeling a lot better. I should have also taken an ibuprofen right before I was streaming, but I kind of forgot. I was really hasty to make this stream work, really eager to connect with all of you guys. Please, we are now exactly an hour into the stream. If you're enjoying what you're seeing, please leave a like. That helps tremendously. Comment. You guys see I love interacting with a lively comment section, getting your agreements, your disagreements, your suggestions, your skeleton emojis symbolizing that that I was feeling so bad. You can support me directly via super chats or super stickers, or you can become a supporter right here on YouTube, or a subscriber over on Patreon, or join our Discord. You know what? To anybody who's watching who might be new, whether you're watching live or as a VOD, I'm actually gonna copy the Discord link, invite members. Never expire. I'm getting a little bit of an expert of sharing that Discord link. Oh, Jesus. You see, I was coughing and Coke cured that too. Coke, please sponsor me. I guess outside of Apple, that's like the one company that gets most of my money throughout the year, unless I count like my the company that like owns my apartment, shit like that, and the company from which I buy gas and electricity from. I forgot my train of thought almost completely. All the colors, 30 minutes, shout out. And I started a super small super chat goal. If you feel like helping out with that financially, feel free to do so. Let's continue, because it's now been an hour into the video, into my video, and we reacted to some benchmarks, but out of this video, we came like 17 seconds along.
Year after year after year. And now we arrive at the M5 Pro and Max in what is likely to be the final iteration of the current generation MacBook Pro, which means you're not gonna buy this thing. You should not buy this thing, because we're going to get a new model in about 7 months.
So I disagree with that approach. Obviously, buy something if you feel the need to. There will be some people who might not be the biggest fans of OLED versus like mini LED. Some people just don't like how OLED looks to their naked eye. I know some people will say, oh, mini LED has like pulse width modulation too, not just OLED. But I've always found that, to me, a very dense mini LED screen, now it won't have all the benefits of OLED. It won't have the pixel level precision contrast. It won't quite have the efficiency. It won't have anywhere near the pixel response times. But one thing, but to me, it has always looked a little bit more pleasant. I'll be honest.
Pro and Max themselves, well, they promise some pretty significant gains. For one, Apple is using a new chiplet architecture, which means the CPU and the GPU are on their own distinct dies.
They're both, though, N3P. So unlike some other companies, for example, the very basic example is that AMD puts their I/O die on their separate chiplet from their CPU dies. And while their CPU chiplets right now are 4 nanometer, their server versions are 3 nanometer. But their I/O die, with the argument being, of course, that full efficiency matters less there, and that I/O controls are more difficult to actually scale down with a more dense node. They're actually 6 nanometer. And interestingly enough, Zen 6 is going to use an N2P chiplet. So an over 2 generation jump from N4, but it might still use a 6 nanometer I/O die.
That's not something we
Wait, WWDC 2026, did Apple announce that? Because I know Apple announced their 50 years of Think Different campaign. They do send out WWDC announcement. Wait, why are you guys talking about WWDC in the chat? You're now confusing me.
expected until the next generation M6 processors. But on top of that, we also have a new core designation. For the past 4 generations, we've gotten used to performance cores and efficiency cores, but now things are kind of rearranged. Instead of performance cores, we now have super cores, which seem to be the same thing as they were, because Apple kind of retroactively named the M5 performance cores.
I cannot find the WWDC announcement, neither on Apple's website nor on their newsroom site. I mean, I can check on 9 to 5. The problem is, if it's just the date, it really, did you confuse it with like Apple's 50-year celebration? Because that's happening April 1st, because Apple obviously was founded on April Fool's Day. It's a pretty famous story that Steve liked to tell. No, I don't see any WWDC announcement. Sorry, guys.
Super cores now, but then the efficiency cores, those are gone, and in their place,
a name that I cannot read. You remember me, we talked maybe a year ago, and I was like, it's reasonable estimation that the M5 Max will be at 20 teraflops FP32, which is now 20 something teraflops FP32. That's M2 Ultra level. Yeah, I'm not sure if I remember the exact conversation, but yeah, the scaling obviously makes sense, right? It does not actually have more GPU cores in that regard, but they keep adding a little bit of clock speed with newer nodes and things like that. So, hey, but you can feel vindicated. I think if you can make these kinds of predictions, I think you will be a great fit for a Discord. You'll find the link to that. I left it in the chat. And you can also type your name, how it's properly pronounced, because obviously I cannot read those letters.
We have performance cores, but not the same as the other performance cores. Somebody needs to get Apple's marketing.
So I actually disagree with that. I think it's perfectly fine to have 2 performance cores with some performance cores that might perform a little bit worse if they are roughly in the same ballpark of either performance or efficiency, especially if it's both. DE cores are, Sully is your name. Well, that helps. That's definitely easier to pronounce than I thought it would be. Thank you. But you're getting, of course, Jesus, there's so many thoughts in my brain. I'm forgetting everything because I'm so tired. Today is definitely not going to be a 3-hour stream, because by the end of it, I'll just probably be asleep at that point. So I was shouting out the Discord. We're talking 20 teraflops. Oh, and then we were talking about core designations. So the 4.6 gigahertz core, though they now have the MacBook Air clocked at 4.4 gigahertz, and they still call it super core, while I believe on the iPad Pro, they actually don't call it super core. even though the iPad Pro is clocked at the same 4.4 gigahertz as the M5 MacBook Air. Geekbench M5 iPad Pro. Guys, feel free to correct me if maybe I dreamt some of this stuff. Yeah, 4,136. That suggests it's actually 4.25 gigahertz. Oh well, now I understand. Okay, so I guess the Super for Apple starts at 4.4 gigahertz, and everything below that is performance cores, because the P cores on the M5 Pro and M5 Max that sit under the Super cores, they're actually clocked at roughly 4.35 gigahertz. So technically still lower than the Super cores on the MacBook Air, which if we look this here, M5, I'm not sure what the search function here can be sometimes very limited. Yeah, Sully, you're saying it's like its own chip. Yeah, it's man, why can I not just M5 MacBook Air? M5, yeah, you can see M5 MacBook Air 4.4 gigahertz, right? And 4.25 on the M5 iPad Pro. So that's something I forgot. No, sorry, that's the M4. But I think the M5 actually clocks the same. Do I just type in Apple M5? They still don't have all the designations. Which of them is the MacBook Air? This looks like the MacBook Air. 4.46 gigahertz, that's the MacBook Air. Well, the MacBook Pro is 4.6 gigahertz, as are the M5 Pro and M5 Max. Okay, we now have a hierarchy. Anything, so I know this is not correct, this will not be Apple's explanation, but apparently we can even look M5 Max performance, if I can type today. Clock speed, I believe it was 4.35. So right under, I told you, yeah, 4.38. That's Reddit from 4 days ago. So I guess somewhere around the 4.4 gigahertz, Apple is making that differentiation. Now, don't forget, of course, the super cores also are architecturally different. They have a different amount of cache. They have a wider out-of-order execution branch. They are up to 10 wide, while the new performance cores are 7 wide. The previous E cores used to be, or are still 6 wide. So there are other notable differences. Yes, should there be 4 distinct names, basically, because of previous performance cores? Now, new performance cores should be called like prime cores, if we're going to go the Qualcomm route. And then you would have something even above that, Apple super cores, and something below that, which is our Apple's efficiency cores. You could do that, but then again, don't forget, Apple tends to mostly only care about the latest generation, and after M5, there will be no performance cores anymore that sit at the top. It will be super cores and E cores and P cores and E cores and P cores and super cores, depending on the exact chip. So, this is why. Is it perfect branding? I'll be totally honest, absolutely not. Is it still more than workable? Yes, it is.
Same as the other performance cores. Somebody needs to get Apple's marketing team and hardware team in the same room and tell them to talk to each other, because I don't know what the hell's going on. But regardless, these new chips promise to be unbelievably powerful, and spoiler alert, they are. So let's dive into it with the help of what I've been working on for the past few weeks, my new open source.
So this is also why I wanted to react to this video, because I actually think this is a really good initiative that he is starting. Let's listen to what he has to say. Scaling should be way better with the M5 Pro and M5 Max, and easier and cheaper. You mean because it is cheaper to add like more performance cores, like the new performance cores with less cache, while previous performance cores, which are now super cores, they're actually some of the biggest cores in the industry. They are bigger than like Intel's or AMD's performance cores. So this is why Apple was able to technically give us only half as many top-end cores. Yeah, I actually agree. And then, of course, then you'll also get the scaling benefits of the chiplet approach. So basically plus I would also argue the performance cores might be better suited for Apple's server architecture, because on servers you probably don't want to run anything at 4.6 gigahertz. And if you're not going to run your super cores at 4.6 gigahertz, well, I guess you could run them at 4.4 on the MacBook Air and at 4.25 on the iPad Pro, but on the server side, that's now just wasted silicon. It makes way more sense to use smaller cores that are more efficient, are clocked lower from the get-go, spread their tasks out over more cores because, again, they're more cost efficient because they're more die efficient. Since a lot of Apple's own servers will probably lean more towards the GPU performance side for stuff like private cloud compute, you probably don't even want many super cores at all, right? Even E-cores might in some cases be enough. Yeah, that's roughly my prediction and why I actually agree with you, Sully. I think this is a very scalable architecture, which I'm not saying that makes it perfect. Obviously, nothing is, but it is kind of the best thing out there right now.
Benchmarking service called Miani Bench. That's right. If you caught my videos last
so
week,
that's the
you'll know that I
initiative I
launched
was
this new
previously
website
calling out
to help
that I think is a
collect
good thing from
user-submitted
him.
benchmarking data so that I can get as much context as possible. Now, this site is still pretty new, so we don't have an interface built out yet for you guys to go and browse the results. But I've spent
and that is why I also did like reacting to like the Blender website directly, because at some point I might actually be looking at Miami Bench just like I look at notebookcheck.com. So I wish him all the best. I think this is a really cool thing, and hopefully this only helps us grow the amount of people who care about Mac performance, Mac scaling, and stuff like that. And hopefully that will help people make more informed decisions. Yeah, with the Gemini models, I think Apple plan to run it on their own hardware. Yeah, I think that it will be a little bit half and half. I think all the base tasks, all the things that have been promised thus far, that's personal context, on-screen awareness, and app intent control. I think these things will be partially on device, but then the more complicated tasks that they like, and maybe follow-up task, and maybe stuff that needs to be needs to have some server data included, that will be partially on device and partially on private cloud compute. Once Apple makes a full, like out of Gemini, who knows, at that point it might be Gemini 3.2, right? And Apple optimizes a little bit their own foundation models for it. If they're going to use something that's now a real chatbot, right? It tells you life stories. It can generate images from you, for you, all that super general chatbot stuff. There are rumors that Apple is working on a full Siri app for iOS 27. So it's also gonna work and look much more like ChatGPT, like Perplexity, like all that stuff, right? So that will probably be now a mix of private cloud compute and Google's own servers with their own TPUs. I still would suggest that it would still be a custom version and not just exactly Gemini 3.2, 3.3, whatever. But we'll have to see. The only reason why I even believe Apple is going to partially rely on Google servers is because Google has a massive infrastructure of TPU servers. TPU are their own kind of like neural accelerators. It's basically custom silicon that they're building together with MediaTek. I believe partially with Broadcom, but I'm not so sure about it. And Apple simply does not have the infrastructure. Plus, depending on what exact architecture Apple is using, Apple has amazing integer 8 performance because they have hardware accelerated FP16, and that can be basically leveraged for int 8. But Apple does not yet have hardware accelerated FP8 or, God forbid, FP6 or FP4. And those things are necessary for more efficient usage in the cloud because they can help you use less memory, basically double your throughput with a similar amount of bandwidth. Apple does not yet have that in their GPU architectures. So at least up until M6, M7, they might also be, obviously they might not have the entire infrastructure of Google, but their hardware might also be technically a little bit inferior, at least in that specific regard. Sully's saying, isn't it ironic though that Apple AI software is so bad? Well, yeah, it depends on your perspective. Don't forget all of Apple's AI software right now, the most things we interact with are super slim models, right? They're designed for on-device. They're designed to be in a sub 8 gigabyte GPU buffer. They're designed to also run super fast. So even if you were to, you could potentially make it run twice as long or do what the latest Grok version does and have 4 versions working simultaneously, and then they'll find one compromise in the end, which is such a wasteful approach to AI design, right? But Apple wants them fast, Apple wants them lightweight, Apple wants them low memory bandwidth, low memory amount and low memory bandwidth compliant, and yeah, that will really keep them down versus what Google can deliver. But basically that's all either, right? Because ChatGPT is mostly cloud stuff. They haven't released good small models in a while. The good small models that are out there, they're versions of Kimi K 2.5, of Qwen 3.5, GLM 4.7, GLM 5, right? These Chinese open source or open weight models. They will have models that will fit into 8 gigabytes or 12 gigs of RAM. I even run some of them myself in Locally AI, a great app. It works on iPhone, iPad, Macs, has a great liquid metal design. But yeah, obviously Apple is in many ways behind, partially because they also haven't released anything new, right? Ever since that ad catastrophe with the Bella Ramsey ads with a Siri version that at least didn't come out. Some argue, like John Gruber, that it didn't even exist at all. Now that Apple, ever since then, has been much more careful in advertising in AI, but also in showing it off at all. This year's WWDC is where it fully changes, because by iOS 26.5, they will have the Gemini-based Apple Foundation models to make those 3 initial AI features work: on-device awareness, app intent control, and personal context. And then beyond that, we're looking at a separate Siri app, full chatbot functionality, an even newer version of Gemini baked into that, with now even more expertise from Apple of customizing it together with Apple Foundation models. And by the end of the year, we'll have even better hardware. Maybe M6 generation introduces FP8 native acceleration, and it literally doubles AI performance, and it allows you to have 2 times larger models in the same amount of memory. That will be a huge boost to both private cloud compute, both on device. So we'll have to see. Also, I hope Apple takes advantage of the fact that NVIDIA aren't making consumer GPUs anytime soon in next year. Yeah, I've argued that point when I was initially talking about the comparison between the 5080 and 5090 laptop GPUs, which are 4 nanometer, versus Apple using N3P. Plus even the fact that the RTX 5000 series wasn't even that much better than the RTX 4000 series. Neither architecturally nor efficiency-wise. Basically, its biggest benefit was using much faster GDDR7 memory.
Basically 13 hours pouring through this giant Excel sheet of all the data that we collected and organizing all that data into
why would you use 13 hours of your time for it? You can use AI. This is one of the things that AI is actually good at. I even use it for some stuff at my work. But also Excel can actually give you pretty nice analysis and shit like that. He called it Excel,
graph
right?
this giant Excel sheet.
Yeah, okay. I hope he actually used Excel because like even without Copilot, there are some ways to extract data out of all this. Please don't tell me he just manually copied and pasted some of that stuff.
All the data that we collected and organizing all that data into graphs. And that should all mean that today's video will have the most amount of context that you've ever seen in any Apple Silicon review. So I'm really excited. Let's dive into it right after a word from today's video sponsor. Today's video is as well as 3.5 power output each. Avoids those ugly your device kept in check.
Damn, that's a long ad. They probably paid him pretty well. Good for him. I can easily skip that. I'm not going to be complaining. Yeah, I would just use Claude. Yeah, here, and when it comes to just very mathematical things, these things will work well on Claude, they will work well on ChatGPT, they will work well on Gemini, like they will work well on like an open source and open weight model. Like you can run them through locally AI, but also you can run them through LM Studio on the Mac. So yeah, this was silly to say he combed over through it for hours. Maybe hours, like similar to how I stream for hours, which is just like learning that stuff, because that's obviously different from just looking at the results, actually learning and understanding them. But if he actually was doing it manually, I agree. I hope not.
Stations, check out the link in the description below. A big thanks to Anchor for sponsoring today's video. And now let's get back to it. So let's dive into this thing, and I want to start with the CPU because this is where Apple has kind of reconfigured things a little bit. First of all, these are the most amount of CPU cores that we've ever seen in a Pro chip. We're sitting
or a Max chip, but yeah, as I said before, the gap from M4 Pro to M5 Pro is up to 30%. The gap between M4 Max and M5 Max is 15%. So the bigger gap this generation is happening on the M4 on the M Pro side. After Apple's experiment by trying to kind of gimp the M3 Pro by giving it only 192 bus, only a 192-bit wide memory bus, Apple got the message from the community, really corrected, maybe in some ways overcorrected with the M4 Pro, M5 Pro. So thankfully, these are very powerful things. And if you are potentially like a coder or whatever other task you're doing that's way more CPU dependent than GPU dependent, and let's say 64 gigabytes is really the max you will ever need, then I think the M5 Pro makes more sense than any Pro chip up until the M1 and M2 Pro, which also had the exact same max CPU as the max variants of their generation.
18 cores. Remember, the M1 Pro had 8 or 10 cores, and that breakdown is 6 super cores and 12 performance cores. But keep in mind, those performance cores are kind of somewhere between the old efficiency cores and our new.
Well, it's not even old efficiency cores because we still have current efficiency cores. I think CPU core count should be the same, and from Pro to Max and above should just increase more GPU cores. Maybe Ultra more. Yeah, Ultra would need more CPU cores because. But for example, one thing that I could see an Ultra chip doing is right now an Ultra chip would basically be 2 GPU dies from the Max, right, or 2 Max dies before that, right? I actually want the Ultra to have more GPU dies than that. I wanted to have 3, potentially 4 GPU dies and give you 120, 160 GPU cores. While on the CPU side, I think having 2 of those CPU chiplets is perfectly fine. 36 CPU cores, there are very few tasks in the consumer space that will even support that many threads, much less that will even scale really well with with that many threads. And then there are also like power consumption questions, like can you even run all those many cores even at full clock speeds at that point? Yeah, like I fully agree. The main scaler should be the GPU. Guys, we have about 4 minutes left on our super chat goal. If you want to throw a quick super chat my way, get your voice heard, support me directly, please consider doing so. Yeah, 120 core M5 Ultra would be an absolute, like, it would be an RTX 5090 killer, even like it would even be like a quadro killer that has like 96 GPU, 96 gigabytes, right? Because obviously even the M5 Max can give you more than that. An 80 core chip would then probably maybe have like 256 gigabytes. That one could have 384, could even have like 768, right? It would be absolutely crazy if they did.
Supercores, it's kind of hard to tell where, but let's give you guys some context. Here is every single Apple Silicon Mac in one graph.
Except for the M5 Max. But don't forget, this is the fully enabled one. So when it comes to the CPU performance, this will maybe give you like 5% more because the overall cooling is a little bit more elaborate on Apple's M5 Max MacBook Pros than on their M5 Pro versions. But it would still be around 9,000. It's over 9,000. Cinebench, and by the way, shout out to Luke Miani for actually testing Cinebench 2026, unlike seemingly every other reviewer who is stuck with Cinebench 2024 or even Cinebench R23, which is so crazy to me. But you can see that the M5 Pro here in terms of CPU performance, wait, no. M3 Pro. Is it so much faster than the M3 Max? Damn. That's I almost didn't believe it. Look, like even over, like I would have kind of slotted the M4 Max almost here. Let me actually, oh, that's so stupid because does Cinebench have a database for their benchmarks? Cinebench 2026 database, multi-core, M3 Ultra, thank you. Let's look at Apple results only. M3 Ultra, M4 Max. Yeah, M4 Max delivers 7,830 points. So my instinct here was actually exactly spot on. Luke, this is something that you got wrong. Now, CPU Monkey does tend to also get stuff wrong, but this is roughly how I would expect it. 1,000 extra points, a little bit over 12%, maybe even close to 15% of an uplift. So this is something that I guess I should kind of comment maybe, or you guys do it, go under his video, correct that. I'm not sure. I mean, his scaling actually makes sense when you look at it, right? But that gap is just super big. And unfortunately, they do not yet have the M5 generations here. I mean, they have the base M5, which, okay, that actually could be 4,367. What does he actually say? M5, 4,456. So it's not too far. So approximately M5 Ultra with 80 cores, 41 teraflop-ish. Yeah, exactly. If because Apple does not downclock their ultra chips, right? They don't overclock them either, but they run at the same, both multi-threaded and full GPU enabled clock speeds. Jiffer saying, how are those A18 MacBooks doing? I'm seeing lots of returns after reviews. Jiffer, please don't be a troll. Where this is the problem. I see like, oh, I returned this, but the same bullshit people who always do this stuff. Like, believe me, the people who are returning their MacBook Neos, they're not even the people who would know to return it or to care, and much less to post about it. Whenever you're seeing, like, if you're looking at YouTube content creators buying something, using it for a while, and then returning it, that's something YouTube content creators do all the time. They do it for the iPhones. Do you think content creators can afford to own every single piece of Apple hardware? That would be ridiculous.
This is Cinebench 2026 on the multi-core.
In raw compute, this is where it gets really complicated, and it's, I believe Mark Cerny, the lead engineer of the PS5 and the PS Pro, he called it flopflation, right? So he talked about it with the original PS5, but also with the PS5 Pro, because one thing that the PS5 Pro did not take from RDNA 3, 3.5, RDNA 4 GPUs is dual issue FP32. This is why the PS5 Pro has 16 teraflops, while technically, if you used the exact amount of performance, but then used dual issue FP32, you could label it as 32 teraflops, right? And realistically, what Mark Cerny said is that the benefits from dual issue compute, especially first generation versions of them, are so minimal that it becomes now a real fool's errand to try to compare teraflops between very different GPU architectures. And we can sometimes try to compare like an Apple GPU core to like an Intel GPU core. When you look, for example, at the base M5 with 10 GPU cores, you will see it's not that far off from Panther Lake's 12-core GPU version, right? Now, obviously, I'm showing it the chip. These are CPU results, not GPU results. Which, again, these results are a little bit wrong. But at least the results for the M5 Pro seem to be correct. Which, when I look at it, by the way, the M3 Max, right? Like, look at this. The M3 Ultra here. Did he look here at the binned M4 Max with 14 CPU cores? That might be the case. This could be the version with 10 performance cores and 4 efficiency cores rather than 12 P cores and 4 E cores. My prediction, Apple is going to wrap chips in their lineup. A-series chips into the MacBook Neo, M5 chips 10 core and 14 core going MacBook Air, M5 Pro and Max going Ultra. Well, it depends, right? Like Mark Gurman predicted like Apple would switch to an Ultra branding. I'm still unsure about that. Thus far, it seems to be mostly relegated to the M Ultra processor, and which, by the way, an Ultra chip does not fit into an Apple laptop, not without a drastically new, super expensive cooling solution, and that chip would have noticeable power profile differences between being plugged in and when unplugged. I had this grasp when they say which version it is. I agree. That's partially why I was confused. Whenever there isn't a label, I automatically assume it's just the highest version. But you know that he is not using it because here in the M3 Max, very clearly, this is exactly half the performance, right? So this is very likely the 14-core M3 Max. This is the 14-core M4 Max. He just didn't label it because apparently he either forgot that they are 14 and 16 core versions, or he maybe forgot that the 16 core version is actually the high end. And yeah, you can even see from how close these results are a 5% difference that these are very similar M4 Pro and M4 Max chips.
Test. And again, a huge thanks to everybody who submitted data for this, and it really underscores just how powerful this new M5 Pro is. We're outperforming the 24-core M2 Ultra, which remember is 2 M2 Max chips glued together.
Yeah, and here 24 cores is correct. It's 8 performance cores and 4 efficiency cores per die. So that's 12 cores per die. That's 24 cores overall. Yeah, this is crazy. And this is most likely very close to the performance of even the Bint M5 Pro chip that would have 5 super cores and 10 P cores.
But let me condense this down a little bit, and we're gonna just focus in on the Pro chips. And here you can see that the M5 Pro is the biggest jump year over year that we have seen to date.
M4 Pro 14 core. I can check that again. This should be mostly correct though. M4 Pro 14 core, roughly 6,000 points. So his numbers are actually a little bit on the higher side here. That's good, because I would rather see it like this than being completely in a different universe.
And that was also true last year. It seems like Apple is accelerating the pace.
Yeah, obviously this is a 50% difference. But this is also now built on a different bus width and everything. So this was a big change in even chip layout. This is also a big change in chip layout, but primarily from its use of chiplets. Plus the change to Super plus P cores. But yeah, like Apple is very aggressive here. And yeah, this is famously a little bit of a regression again. There is one down like here. Usually the fully enabled Pro chip is next year at least met by the Bint Pro chip, and that was not the case when moving from M2 Pro to the Bint M3 Pro. Well, now you can obviously see here that if you imagine here a theoretical 15-core chip, that still would come out most likely ahead of the 14-core M4 Pro, right? Maybe even be somewhere around here.
Which they're improving these chips, which is nuts. But of course, we do also have to keep in mind that the M5 Pro is also the largest CPU that Apple has put in a Pro chip. We've got 18 cores here. But it's also doubly interesting from a value perspective, because in my next video, looking at the M5 Max, which is laying...
we might look at that point. Sully saying you gotta go, but it was fun chatting with you, bro. See you, chat. See you, Sully.
Wait for me to test here. They have the same CPU cores, and that's something that used to be true.
I'll soon be like after this
video.
I'll have to be wrapping up, because otherwise it's like this will turn into an over 2-hour stream, which is already much. But if it gets anywhere close to 3 hours, I might just die in front of your eyes in a video game.
And then for M3 and M4, the CPU counts were slightly different, and now they're back to being the same again. So going from the M5 Pro to the Max is gonna be an even tougher sell this year, because for an extra $1,200, the only thing that you're getting is...
There is a little bit of news from iFixit saying that the MacBook Neo has the most accessible Mac battery in over a decade. What kind of score did they gave it a repairability score still of 6 out of 10, but that's still better than the M5 MacBook Pro with 4 and the M4 MacBook Air at 5. So it's not quite as much better as some people had hoped. They are downvoting it for soldered storage and RAM, which I hate it when they deduct points for unified memory, because I think we should have learned by now that like all these other solutions, they do not work as well as like whenever you can, like you can technically add LPDDR memory as like a RAM block, but it's not as good as soldered, much less like directly combined with the with the die.
Extra GPU cores and a little bit more RAM. But let's move over to Blender Classroom to see if these results hold true in real-world scenarios.
Cinebench is not limited by the memory amount that is going to be in this in these chips, Jiffer. Like the maybe there could be some, but even then, not on Cinebench CPU. There might be some problems if you test like Cinebench GPU, if you look at like 8 GB GPUs or less, but all of these chips will not be limited. They will be limited by memory bandwidth potentially, and of course core count, core clock speeds, but they will not be limited by memory amount.
And sure enough, here, thanks to Miani Bench and your guys' submissions,
So Blender Classroom, M5 Pro, we see M5 Pro. We actually see almost like, I'm not saying this is actually double. But it is a super significant ray tracing advantage.
I think it's very interesting to see that the M5 Pro was actually slightly faster than the M4 Max, and pretty noticeably faster than the M4 Pro. But what I think is most impressive is that the M5 Pro is 30 seconds faster than the M2 Ultra. And that thing has 24 cores, 16 of which are performance. So the just brute force of these M5 cores is remarkable. But let's switch gears and look at the GPU, because this time around Apple has put a neural accelerator in every single core, and they're claiming that ray tracing performance is dramatically improved, as well as just general GPU compute, which is great for AI, for rendering, all of that sort of stuff. And sure enough, in Cinebench 2026 on our GPU score, now this benchmark isn't a part of Miani Bench, so I only have the device.
And this is also like GPU is really not the Cinebench GPU is just really not the best test in general. Gonna check my channel. Sorry guys, just for a second, seeing how well my video works. Jiffer, you can take a half-hour timeout.
That I was able to test here, but even so, the M5 Pro is more than 40% faster than the binned 16-core M4 Pro in my Mac Mini, which means that Apple's claims of roughly 35% GPU gains year over year seem to be fairly accurate.
Yeah, and the same scaling can also be seen in like Geekbench GPU scores. Obviously, we have reacted to that. So thankfully, at least the scaling between Apple chips to Apple chips seems to be quite respectable here. It is a bit more complicated once you start testing between platforms and everything. Not that Geekbench is perfect at that either. Both Cinebench and Geekbench, in my opinion, are much more suited towards CPU test. Geekbench also does some decent AI testing, though.
I mean, think about it this way. The M5 Pro is only about 33% behind the M4 Max, despite having half the GPU cores. That is pretty impressive. But moving back into Blender for some more real-world applications, I also have a ton of data for this from Miani Bench, and here you can really see just how powerful this is. The M5...
Yeah, we just looked obviously at the Blender benchmarks. We see once again incredible scaling here from one generation that really outpaces that those raster improvements. Riley saying, "What's with the chat today?" Jiffer tends to really put himself into a little bit of a rage. He finds some one topic to fixate about, and then I'll mute him after a while. It's fun for me. And then the chat becomes deleted, whatever was the contribution of him. I hate that when I put somebody in a timeout, I don't actually want their chats to disappear. If I were to block somebody, then I would want their chat to disappear. It's a little bit strange on their YouTube side, or at least the way it's configured for me right now. But yeah, if you're wondering why the chat looks a little bit like a graveyard, it's because I muted Jiffer.
Pro is only 3 seconds off of the M4 Max, and it shaves nearly 10 seconds off of the equivalent core count M4 Pro.
And we now saw how that obviously scales, because this is 17 seconds, right? But obviously we have those points, like the 3,700 points in Blender 5 benchmark. So, and how that then compares versus RTX 5000 series GPUs. I hope that the scaling actually allows you to have you can see from 26 seconds to 14 seconds, these are very 2x scalable results, basically. For exact scaling, this would have to be 13 seconds, or this would have to be 28 seconds. But there will also be some run-to-run variants that will explain it. So, and you can see that the M5 Pro is also almost twice as fast. For exact halving, it would have to delete 1 second here or add 2 seconds there. So by that logic, M5 Pro will then be, M5 Max will then be 9 seconds. Riley saying it looks like 3 people with 20 messages in a row. Yeah, almost for a while. That's like Colin Ferguson also spammed quite a little bit. I guess I missed that almost. Yeah.
That's crazy. I mean, this graph
Well,
is
Riley, you have to yap more. Then you can offset that. And Riley, you regained the crown after I timed out Jiffer.
unbelievable. Look at the M1. Almost 4 minutes. We're down to 17 seconds on the M5 Pro. And again, let's isolate only the Pro chips. Look at how fast those render times have come down. And that's in less than 5 years. Remember, the M1 Pro launched in October of 2021.
More like this.
That is how fast
this.
this has happened. In Cyberpunk 2077 on the 4K ray tracing.
So this is something that we're gonna end the video out on today. Not right here, but I do have a list of gaming benchmarks thanks to a Reddit user who has both M4 Max and M5 Max. I would love to have those same games with the same settings on like RTX 5000 GPUs and stuff like that. It's not something I'm gonna have today, but that's still something I would like eventually to get to.
Preset. This thing is actually performing just 1.4 FPS shy of the 40-core M4 Max. This M4 Max MacBook Pro has 2 times.
Yeah, you can see that, especially when it comes to ultra ray tracing. That's something we see a lot on the PC side with NVIDIA ray tracing versus AMD. While you're doing very basic ray tracing, very basic reflections, shadows are like the easiest RT, or you have global illumination without the highest fidelity. NVIDIA and AMD are not too far behind or ahead of each other, but once you add all the RT effects together, shadows, reflections, and ambient lighting, ambient occlusion, stuff like that, right? If you push them up to even higher settings, like path trace settings, then NVIDIA starts to outperform AMD by like 2-3x sometimes. You can see a little bit of that here, right? While we saw some results where it's like 30 or even 50% faster, right? Now the M5, oh, did he screw up that benchmark? Because the M4 Pro and the M4 Max, I think the M4 Pro should have been a 16 here. Yeah, I don't think that he screwed up by this being correct. I think this is, and the rest being wrong. I think this is the only wrong thing, and the M4 Pro comes in at a 16 rather than 26. So there are some mistakes here, some labeling on the graph, and maybe some graphs not perfectly drawn. Maybe AI could have helped you with that, Luke. Again, I still respect the work you put into this, but this is a very clear outlier. But yeah, if this is 16 to 23, that's an almost 50% increase. So you can see how a newer GPU architecture really starts to outperform once you go not just with 4K, not just with ray tracing, but now 4K ray tracing and ultra. This is now where new architecture really comes to shine. On NVIDIA, this is where GDDR7 memory would help you out, because now these tasks also become partially memory bandwidth limited. So just something to keep in mind. You will not see 50% scaling, but necessarily at lower resolution, at lower ray tracing quality, or at lower overall game settings.
The number of cores, and it's only 1 FPS different. That is how much faster the ray tracing is in this generation. That is crazy. But if we lower the settings and we look at 4K on medium without ray tracing turned on, you can see
That's a stupid setting. You never do 4K medium. You do like 1440p high. That will usually look better. Also, in this test, he does use Metal FX temporal scaling.
M4 Max does a little bit.
So some of the benefits might also come from a better neural engine and a better neural accelerators on the GPU, which are processing Metal FX. And there will be question. I don't know if Apple uses a new Metal FX algorithm on newer GPUs. I'm waiting for all of these clarifications at this year's WWDC. I have so many questions about like whether it's just Metal 4, but now more information given that we have M5 and everything out there. Maybe Apple introduces Metal 5 and even more features. Hopefully a game like Crimson Desert also tells us more by being built with Metal 4 in mind, not even porting it later, like Cyberpunk might do. Yeah, but you can see here that the scaling now becomes much worse.
Better. Now, this is still ridiculously close, given that we have half the cores again. But still, it is worth noting that...
But now you also see that there was very poor scaling here. And this scaling really seems to be wrong, in my opinion. And I'm not actually blaming this on him. Well, this could... Now I'm not sure if this is the 32 or the 40 core M4 Max. Jesus, he should really label those. Because he does label it on the M3 Max here, specifically that it's 40 core. He labels the core count on the Ultras.
Application can handle ray tracing is going to be a factor in how much you're able to take advantage of this. This is making me very excited to see how the M5 Max does, because if this is any indication, that thing's going to be a monster. Quick aside for a shameless plug before we move on to the next test, you may have noticed there was a lot less data in Cyberpunk than I had for like Blender and Cinebench. Well, yeah, it turns out not that many of you guys have Apple Silicon Max and also have Cyberpunk on it. Fair enough.
Or at least you're not running necessarily the benchmark on it.
Necessarily the platform I would choose either. But if you do, especially if you have M2 or M3 Pro or Max chips, and you also have Cyberpunk, run it, submit it, get me some more data.
I'll probably do that with my M1 Max. It's not one of the chips he asked for, but maybe that helps.
By moving over to Shadow of the Tomb Raider at 1440p.
So Shadow of the Tomb Raider is a good game, graphically intense. It's also written for x86. It's not written for ARM natively, so it's running through Rosetta translation. Keep that in mind whenever you see Shadow of the Tomb Raider benchmarks on macOS. They are translating really well through Rosetta, but they are not a native game.
High preset. Here we saw that the M5 Pro, weirdly, is actually lagging behind a little bit. I think that's because this is an older game. It's not able to take advantage of the optimization as much. But again, test after test after test, we're finding the M5 Pro is right next to the M4 Max. Like, I'm kind of speechless.
Which this does actually suggest to me that this is the 40 core M4 Max, but now it's labeled, and now I'm wondering why wasn't it labeled before.
Guys, this is unbelievably powerful. And finally, in Death Stranding at 4K on the high presets, this is not one that I can have on Miani Bench either because it's harder to measure. We see the M5 Pro pretty much holding that same pattern.
That's insane. I'm not sure. Like, it's written on the Decima engine from Guerrilla Games, the PlayStation studio that makes the Horizon games. And this engine does not have ray tracing, so I'm really surprised at seeing this extreme scalability, well over 50%. Like, just to give you an exact number, 68 divided by 43. That's 58%. And Apple did promise on their website that some gaming stuff could scale up to 60%. So that's really cool.
How much faster it is compared to the M4 Pro. I was able to get a friend to
Riley, how is it not if it's on Mac App Store? Mac App Store still has older x86 games. There's a requirement for new games to be Apple Silicon compliant and macOS Tahoe compliant and stuff like that. But old x86 games are still allowed. They will just potentially not run.
the 20-core version, so we have a 1-to-1 comparison. I mean, my goodness. In fact, you may also have noticed the M5 Pro is outperforming the M3 Max. This is just ludicrous.
And this is in just 2 years, mind you, right? So this is something that specifically needs to be now kept in mind versus like the jump that NVIDIA did, or more precisely, did not really do from the RTX 4000 series to the RTX 5000 series. If the jump to RTX 6000 ends up being not super impressive, by the end of next year, potentially, Apple in the meantime will have introduced another 2 generations. That is absolutely crazy, like absolute bananas, and how much Apple might be ahead at that point versus NVIDIA. Like, sure, maybe NVIDIA will still be like the absolute king when combined with their super huge GPUs, that just the GPU side is larger than the max combined CPU and GPU die, and you have the GDDR7 memory, at which point might be up to 38 gigabyte per second modules, right? So that would be a total of even more than that, closer to 2 terabytes of bandwidth. Wait, what's the bandwidth of the RTX 5090? I don't want to say something too ridiculous and make NVIDIA sound too good without asking for some money from Jensen Huang. RTX 5090, I mean, shouldn't it be basically exactly double the memory bandwidth of the RTX 5090 mobile, which is almost 900? Minus like 10% because the RTX 5090 does not utilize the fastest bandwidth. Bandwidth. AI. Oh, it's 1.8 terabytes per second. So yeah, and this is on 28 gigabit per second modules. So if they use like 36, 38, roughly a third of improvement, that's going to be 2.4 terabytes per second. That's now going to be twice as fast as the M5 Ultra, unless Apple goes crazy and gives us 3 or 4 GPU chiplets on the Ultra rather than 2.
And I know that nobody's going to buy this MacBook because there's a new one coming in a couple months that's going to be even faster. I can't help but
I don't think that the current response on the market suggests that nobody wants to buy this. Like, I think there's actually a decent amount of excitement.
Excited for when this chip comes to the Mac Mini.
A lot of people want the device right now for all their AI stuff and things like that. While sure, people who are like more into content creation, they could wait. They will likely wait for tandem OLEDs. But maybe you have a MacBook that doesn't take great advantage of the Studio Display XDR, and you want a Mac that takes full advantage of the Studio Display XDR. That's now money to consider. Maybe you'll need a storage upgrade right now, and that 2 times faster storage at the same pricing suddenly looks very enticing.
Because that's going to be like $1,400 or $1,500 to get the full M5 Pro with 20-core GPU. That is going to be a ridiculously good value. So now let's switch gears and talk about video editing. This is a classic staple for the Apple Silicon MacBook Pro.
And that's something I can actually speed up even further.
For good reason. They're really, really efficient. They're able to go and work on
timelines
talks really
slow for 1.4 to still be super understandable.
But this is also one of the areas where Apple Silicon has improved the least, frankly, much to my frustration. Because way back in the very beginning with the M1 Pro and Max, Apple unveiled these media encode engines, and they are really, really freaking good. But they haven't really gotten a whole lot better.
Yeah, they got like 25% better. Apple really should do something with ProRes, but I think Apple is really torn right now. Apple refuses to implement AV1 encode. They have decode for like YouTube video, Netflix video playback, just for the efficiency of it all. They do not have AV1 encode because technically AV1 might be a bit better than H.265, but then it sucks balls versus ProRes. So it would take AV2 not just launching, which is still a little bit off, but then also being really successful, I think. So it might be another 2 years or so that Apple might introduce a new encoder of a kind. But who knows? Maybe in the meantime, M6 generation will have brand new ProRes encoders and stuff like that.
So when I asked you guys to submit data and I collected data from all of my machines, I was surprised when the graph looked like this. For the most part, the Pro and Max chips are exactly the same.
So as far as I know, the Final Cut 4K. Okay, so this data is worthless to me because he calls it up 4K project render, which by the way also suggests that this is a very small project. If it can be exported in 46, 47 seconds, it's really not a great test because you can see if you can do something in 3 minutes on the base M1 and M2, you probably are not going to spend $5,000 to render it under a minute on the M5 Pro or M4 Max, whatever. You can see that it got noticeably better on because don't forget, so he does not have M Pro or M1 Pro or M2 Pro chips, but they should be very similar in speed. Which M1 Max here seems ridiculously overpowered because M1 Max has 2 times the media engines of M1. So does this somewhat benefit from the extra GPU power? Would the M1 Pro then be somewhere here, and then this would be here, and then have that with double the engine? These are somewhat weird results because I firmly remember M5 being at least a little bit faster than M4, but then he has M4, but he has no base M5. Is base M5 here now the same as the M5 Pro?
Same. My demo project, which is available on MianiBench.com, whether you're rendering on a 5-year-old M1 Max or a brand new M5 Pro, it's gonna take 46 seconds. You can try it for yourself. You'll see exactly what I mean. It's these media encoders are doing all the heavy.
But the problem is it matters what encoders you're talking about. Nobody's really improving H.264 that much. You're probably gonna improve H.264 decode more nowadays just to make video watching online more efficient. Then for the same reason you will improve AV1 decode. And then if you really want to improve a rendering codec, you will probably work on ProRes and on H.265 or HEVC. So if he uses an H.264 project, that would explain the relatively poor scaling.
So, frankly, it doesn't really matter how fast your CPU and your GPU are for at least the render portion. If we move over to the export, well, things change a little bit. Here you can actually see the chips improving year over year. Though, to be honest, again, this isn't a huge update given how much more powerful this computer seems to be.
Again, these projects are also way too small to totally benefit from all the things. It also, I wonder how extensive the actual, like if this is just a timeline of like one video project with another, maybe some titles, the basic YouTube project that kind of like this video, which I'm not saying actually in negative, like not everything has to be super elaborate and overproduced. M5 is here a little bit slower than M5 Pro, but roughly in line with M4 Pro. Yeah, I would need to know what the encoder he is using here because otherwise it's a pretty worthless. These are pretty worthless numbers for me.
Once again, I think
ironically, guys, guess until which part I watched the video.
Coding engines are doing a lot of work here.
And so that's probably why when I was super positive, I did not know that it was going to go a little bit downhill here.
How powerful you make the M5 Pro, it's not going to beat an Ultra because it has 2 Max chips, which means 2 media encoders. And that's why it's, wouldn't you know it?
There are also better tests even for like video editing. Now, this is probably not going to be very impactful on a project that is this fast to render. But sometimes like, can you actually play back your video at full 24, 30, or 60 FPS? How much is it impacted once you're editing more advanced effects? And how does your GPU help out with that? These things are not really captured by the export phase that much.
About twice as fast.
Or at all
we see the same thing
ways.
in DaVinci Resolve with the 4K timeline that's on Miani Bench, which I got a decent amount of data. And it seems like DaVinci is really able to take advantage of the higher core counts because we can see the Max chips doing better.
Yeah, it's probably using better GPU acceleration. But then also my question is it even that much? because if this is the same project, Final Cut seems to be less limited and seems to be faster in the export here. Like even on the M4 Max, it's 1 minute and 12 seconds versus 1 minute and 23 seconds. On M5 Pro, it's 2 minutes and 3 seconds versus 1 minute and 39.
Line that's on Miani bench, which I got a decent amount of data, and it seems like DaVinci is really able to take advantage of the higher core counts because we can see the max chips doing better. But once again,
the M2 Ultra here
because it just has
gets its rare W
times the median.
But yeah, this also clearly suggests that this is primarily limited by GPU speeds.
Now, to be honest, I was kind of expecting just a little bit more here, not least because of the new SSDs in these new MacBooks. Apple had claimed...
Again, these projects are too small to really benefit from it. If you can export it in a minute, then that means the actual amount of time that it's actually being exported from the storage, not being encoded and then exported, because technically the export is part of two things. It's the encoding and the actual exporting. If your project takes 1 minute in the final export, then the amount of time that it takes on the SSD is like 5 seconds.
Up to 14 gigabytes per second read-write speeds, which is pretty nuts, but I was kind of bracing for the fact that maybe this would only apply to the Max chips or to models with 2, 4, or 8 terabytes. But I'm happy to report that my 1 terabyte base M5 Pro over here has ridiculously fast SSDs. Wasn't quite 14, but we're talking about 11 or 12 gigabytes per second read-write.
The lower storage versions will be a little slower. It also depends a little bit on the exact test, like how large your file is and stuff like that.
SSDs available on the market. And when we compare that to my M4 Max MacBook Pro, I mean, my goodness, these things are just redonkulously fast. So what are the takeaways that we learned here? Well, I think that the M5 Pro chip is really proving that platform, which means
okay, so in terms of benchmarks, we're actually done. I don't think we'll need that many more conclusions from him. The last data set that I would like to react to here is actually from a great Reddit thread. M5 Max versus M4 Max, better performance than expected. At r/MacGaming, posted by some of my guys in Discord. Thank you again, whoever it was. I tend to forget. I think it was the guy with the wave emoji in the name, but I never know your name because all I see is the freaking wave emoji. And thank you to EKSI or EXI or XI. So 16-inch M5 Pro, M5, 16-inch M5 Max MacBook Pro, 14-core, 48 gigabytes of RAM, but we are not limited here. 2 terabytes SSD. So this is the base M5 Max, but on the 16-inch, and then on similar to that actually, but here with 1 terabyte as an upgrade over the 512. So yeah, very comparable. Not going to be either have different memory capacity limits. Storage speed limitations would probably not really come into play. So he tested Cyberpunk. I just assume they tested Cyberpunk. M4 Max, Cyberpunk. So we have a 19% improvement. This is interesting resolution, by the way, 1460 by 2336. Is this 2/3 on each axis? No. Is it 75% on each axis? I think it is. But it's a roughly 20% improvement. So that's actually very much in line with what Apple promises without ray tracing. And with ray tracing, now this is RT Overdrive, it's 40%, which actually is a little bit more. Apple tends to promise around 35%. Shadow of the Tomb Raider, again, a non-native game, so it might be overcoming some CPU limitation here, but man, or maybe whatever translation layer in Rosetta is written, it might vibe very well with the M5 generation. 50%, massive improvement. In Control, very little improvement of under 7%. But then once we add ray tracing, we get to actually basically the exact promises that Apple made. So this to me suggests that there might be some issues overall with the raster performance. Baldur's Gate, though, 58%. So clearly some games can scale no matter RT or not. Expedition 33, now we are looking at crossover. So these are Windows games that are being forced and translated to run on the Mac. 33% actually above 30 FPS, which is necessary even for a game like Expedition 33. Horizon Zero Dawn Remastered, 11%. That's a little bit underwhelming, especially since the resolution is so low and it's running on the same engine as Death Stranding. So at this resolution, I would expect it to be more in like the 80 to 90 FPS range. But then again, this is crossover, so there will be translation overhead issues. But you can see Alan Wake 2, a game that's visually more demanding than this, 71% in 71 frames per second, 30% improvement gen on gen. And then in ray tracing, this is RT Medium, no DLSS ray reconstruction. Apple is working on their own version of ray reconstruction. Hopefully that shows up in Cyberpunk Metal 4 version, in Crimson Desert Metal 4 version. But we have a massive 76% difference. I would love to know how that the weird resolution unfortunately holds us back a little bit, but I find it funny that even RT Medium causes this immense drop here. But you would also probably want to, especially on NVIDIA GPU, you would want to run this with ray reconstruction, because ray reconstruction in this case is not just going to make it look better, but it might actually make it run better too. And then actually, thankfully, this person also added even more benchmarks just yesterday. The one outlier here is actually World of Warcraft, that has seen some degraded performance. And seemingly with MSAA on, performance is still up a little, but barely noticeable. But then with MSAA off and like this is Dragon Scale Expedition, so this is this is Thaldarajus in Dragon Scale Expedition Base Camp. So this is where we see our one and only performance degradation. The rest, you can see Resident Evil 4 Remake does not use ray tracing, at least I'm not sure if it's enabled. 20% uplift, 22% uplift at higher resolutions, 26% uplift when using Metal FX. So we could be seeing some benefits here from the faster neural engine, the faster neural accelerators that are built into the GPU. Now we're looking at a crossover game in Red Dead Redemption 2, and we're seeing 25 to 36% improvements. So very much in line with what Apple promises. Very nice to see that kind of scaling even on a non-native game. And then Baldur's Gate 3 here, again, native game, I assume native resolution here now, 40.4%. So if we go actually to Apple Newsroom, I don't quite remember which game they promised 60% uplift. I think it was Cyberpunk though. And I'm not actually sure if they said that in Newsroom or Mac. So MacBook Pro. Performance, 80% faster, 8 times faster in AI. M5 Pro. Here's M5 Max, 16-inch model. You can see, by the way, that the scaling is a tiny bit different on the 14-inch because it will be more impacted by slightly higher power consumption. And yeah, you see Cyberpunk 2077 promises 1.5 times. So not 60% faster, but 50% faster with ray tracing. So even above Apple's 35 to 40% promise for things like Blender. In fact, this is also something that I should look up. And this is, what's the M4 Max performance with Blender 4? 5290, that's versus 7136, so 7136 divided by this 5178. How much is that faster? This is 37% faster. So seemingly, when Apple promised roughly 35% improvements for ray tracing, that seems to have been actually more related to like Blender rendering, 3D rendering. While if you're running like real-time ray tracing and you're stacking more effects in higher RT settings than before, this is where you now might be looking at up to 50 or even 60% gains, which is obviously great if you can get that. Thank you guys. Thank you for anyone who joined. Thank you for anyone who commented. Now I'm really feeling like a deflated balloon at this point. This was super interesting to summarize and just get a better handle on the topic of benchmarks for the M5 Max. Might be back on Sunday, depending on how interesting Mark Gurman's Power On newsletter is. But now I'm really getting in my very, very busy phase. So mid-March to mid-April will be extremely busy. And then afterwards, I will actually be much, much better off for a little while. I might start my streams later because my days are longer, but I will have to do less like homework basically from work. So hopefully you're looking forward to that. If you're watching and enjoying this, whether live or Savant, please like the channel. Please subscribe to the channel, like the video, share it out with anybody who you think might enjoy it. Comment. Don't just comment live. Comment afterwards on the VOD. And of course, you can support this channel directly whenever you catch me live. Leave a super chat or super sticker, goes a long way to help me out with the channel. Shout out again to all our YouTube channel members, which you can also become one of. I already gave a shout out early on to the MarkTech Pro members. Second shout out of the day to our MarkTech Pro Max members, Angelica, Steve, Max, Maximus, and Jonathan. And of course, you can become a supporter over on Patreon. You can join our Discord. I left the link for that in the live chat. You'll also find it in the description of this channel. And you can follow me on Twitter. Sometimes I'll post fun tech-related stuff over there as well. And I tend to get a tiny bit political, which hopefully you enjoy too. But yeah, that's about it for today. I really, really enjoyed it, but now I really, really need to take a nap. I'll see you soon. This is MarkTech, tuning out.